Hi there! In this video, we will discuss the key probability concepts that you will encounter in SAT math. Probability is a branch of mathematics that deals with experiments, and we use probability to predict the likelihood of an outcome. For example, having 2 boys and a girl in a family of 3. So the idea is to construct a tree diagram and list the possible outcomes. So you could either have a boy or a girl. If you had a boy, you could have a boy or a girl again. If you had a boy, you could have a boy or a girl again. If you had a girl, you could have a boy or a girl. And this is your 3rd child, so you want to stop here. If the first child is a girl, you could have a boy or a girl. If the second child is a girl, you could have a boy or a girl. If the second child is a boy, you could have a boy or a girl. So here's the list of outcomes. You could have a boy, boy, boy. You could have a boy, boy, and a girl. You could have a boy, girl, and a boy. You could have a boy, girl, girl. You could have girl, boy, and a boy. Girl, boy, girl. Girl, girl, boy, and girl, girl, girl. The question is, what is the probability that one could have 2 boys and a girl? There's 2 boys and a girl, 2 boys and a girl, 2 boys and a girl. So there are 3 possible ways in which you can have 2 boys and a girl. So the probability of having 2 boys and a girl is 3 out of 8. The other concept is AND versus OR. The word AND in probability means intersection, and this is the symbol. And the word OR means union, and this is the symbol right here. For example, if you roll 2 fair die and you let event E be getting an odd, which is 1, 3, and 5, and the event F would be getting either a 1 or a 2, E union F would be all of the numbers 1, 2, 3, and 5. E intersection F is going to be only 1 because only 1 is repeated in both sets. The probability of getting E would be 3 out of 6, which is a half, and the probability of getting event F would be 2 out of 6, which is a third. The probability of getting E intersection F, which is AND, you simply multiply the 2 probabilities, and that's your final answer. The probability of E union F is a little bit complicated. It depends on whether they're mutually exclusive or not. But for now, we will simply count, which is 4 out of 6, which is 2/3. To find the probability of the union, it's best to use the equation probability of E union F is the probability of E plus the probability of F minus the probability of E intersection F. And in our previous example, we had the probability of E is a half and probability of F is a third. So you can say a half plus a third minus the probability of E intersection F, which was a sixth, and we get 2/3, which we had determined experimentally by simply counting. If the events are mutually exclusive, which means there are no intersection, then you can simply say that the probability of E union F is probability of E plus probability of F, and you do not have to subtract the intersection piece there. So this is only if it is not mutually exclusive. If it's mutually exclusive, then you can just use this equation here. There is another concept, complement rule. If you have probability of E plus the probability of the complement of E, which is not E, is equal to 1, which means probability of event E occurring plus the probability of E not occurring is 1. You can think of it as probability of E union, probability of E complement is 1. Now, if you have E intersection not E, it's a null set. It's not possible to have an event occurring intersecting with the same event not occurring. So here's an example. If the probability that it'll rain tomorrow is 60% or 0.6, then the probability of it not raining tomorrow is 1 minus 0.6, which is 0.4. So here's an example of how we can use the complement rule. If the probability that John will buy a certain product is 3/5, and the probability that Bill will buy that product is 2/3, and the probability that Sue will buy the product is 1/4, what is the probability that at least one of them will buy the product? So at least means that if one buys the product, then the others do not. So the probability that John buys the product is 3/5 and John not buying the product is 2/5. Probability that Bill buys the product is 2/3 and Bill not buying the product is 1/3. And the probability that Sue buys the product is 1/4 and not buying the product is 3/4. So the probability that at least one of them will buy the product is 1 minus the probability that none will buy the product. So it's 1 minus the probability that none will buy the product would be 2/5 multiplied by 1/3 multiplied by 3/4. It's 1 minus 1/10, and the final answer is 9/10. The ELISA test is used to screen donated blood for the presence of HIV antibodies. When HIV antibodies are present in blood tested, ELISA gives a positive result 98% of the time. When HIV antibodies are not present in the blood tested, ELISA gives a positive result 7% of the time. And it's of course a false positive, because if it's not present, then you do not have HIV, and 7% of the time it tells you do. The question is, what is the probability that a positive ELISA results for a unit of donated blood is accurate? So in other words, what is the probability that your test is accurate? How reliable is this test? Let's go ahead and draw a diagram so that we understand what's going on. So here's your unit of blood donated, and then you have two outcomes. You either have the antibodies or you do not have the antibodies. And if you have the antibodies, you are either going to have a positive result or a negative result. If you do not have the antibodies, you're either going to have a positive result or a negative result. So let's just say antibodies present, and here it's absent. To determine the probability that the antibodies are present or not, you need more information. And here's the information. 1 out of every 1,000 units of blood, every 1,000 units of blood contains HIV. Actually contains HIV. So we do know that if the antibodies are present, it's 1 out of 1,000. This is the probability that you have HIV antibodies is 0.001. So 1 minus 0.001 is 0.999. Okay, let's just say that this is a positive test, negative test, positive test, and negative test. Okay, the question tells us that if the antibodies are present, there is a 98% chance that it will give you a positive result, which is the accurate result. But if you don't have it, there is a 7% chance that it'll tell you that you have a positive result. So the complement of 0.98 is 0.02, and the complement of 0.07 is 0.93. So if you multiply 0.98 by 0.001, you will get 0.0000098. And the chances of getting a positive ELISA test and a positive antibodies is 0.00098. Now there is a false negative here, where your ELISA test is negative, but you actually do have the antibodies. And if you multiply these two numbers, you will get 0.00098. 0, 0, 2. Now you don't have any bodies here, but it tells you you do, so it's a false positive, and the chances of that happening is 0.06993. Or you don't have the antibodies, and it tells you that you don't have it, so this is an accurate one. It's 0.92907. And your total should turn out to be 1. It should be 1.0. The question is, what is the probability that a positive test would result for a donated blood is accurate? So the answer would be 0.00098 divided by the total positive, which is 0.00098 gives a positive ELISA, and the other positive ELISA is 0.06993. And the final answer would be 0.014. Okay, how about you try this, pause the video, and then run the video again to get the answer. Okay, did you get B? Let's go through this. The probability that Giants will win the NFC Championship is P, and if the probability that the Raiders will win the AFC Championship is Q, what is the probability that only one of these teams will win its respective championship? The probability that Giants win is P. Probability that Giants lose is, of course, 1 minus P. Probability that Raiders win is Q, and probability that Raiders lose is 1 minus Q. The probability that one win means that the other one must lose. The probability of Giants winning is probability of Giants winning times the probability of Raiders losing. Let event A be probability of Giants winning, which is probability of Giants winning times the Raiders losing. Let event B be probability of Raiders winning, which is probability of Raiders winning times the probability of Giants losing. Because Raiders can only win if Giants lose, and Giants can only win if Raiders lose. So we have P times 1 minus Q for Giants winning, and Q times 1 minus P for Raiders winning. Now the question is, what is the probability of event A or B? Which means you have to have event A, probability of event A plus the probability of event B. So doing a little bit of algebra here, P times 1 minus Q plus Q times 1 minus P, distributing it out, collecting your like terms will give you this choice B. I want you to pause the video again and try this one. Okay, did you get C? Let's look at this. There are 7 orange discs and 5 green discs in bag X, 7 orange and 5 green. And there are 5 orange discs and 15 green discs in bag Y. If one disc is selected at random from each bag, what is the probability that both discs selected are green? So let's call event X selecting green from bag X, and there are 5 green, so the chances of selecting green would be 5 out of the total, which is 12. And the probability of selecting green from bag Y would be 15 out of a total of 20. Reducing that will give you 3/4. The question is, what is the probability of event X and Y happening? And the formula is probability of X times Y, which is 5/12 times 3/4. Reducing it will give you 5/16. Moving on to the next question. Pause your video and try this. Okay, the answer for this is E. Let's go ahead and inspect the choices. The first one is A intersection B intersection C. If it's A intersection B intersection C, this piece would be shaded. The second one is B union C union A, so everything should be shaded. The third one is A intersection B union C, so this piece would be shaded. Choice D, B union C is B and C combined, and then you want to get A intersection B union C, you'd expect this to be shaded right here. A union B intersection C is what's given in the figure, so the correct answer choice is E. Moving on to another one. Again, pause your video and try this problem on your own. Okay, the correct answer for this one is A. To figure out the total outcome, you have to look at the number of events and raise it to however many times you flip the coin. So let's read the question together. If 10 coins are to be flipped and the first 5 all come up heads, what is the probability that exactly 3 more heads will be flipped? Well, to begin with, each of the 10 coins is flipped 5 times and it's an independent event. So the outcome of the first 5 flips has no bearing on the outcome. So it doesn't have any effect at all. First of all, let's figure out if you flip one coin 5 times, each coin has 2 events. Flipped 5 times will give you a total of 32 outcomes. The number of ways in which you can get 3 heads out of 5 flips is 3 chosen from 5, and on your calculator you can get 10. Please view my video on permutations and combinations to see how this is done. The probability of getting exactly 3 heads is the number of ways in which you can get 3 heads out of 5 flips, which is 10, divided by the total outcome, which gives you 516. Plug that in your calculator and you get 0.3125. Again, pause your video and try this, and I'll see you back in a bit. Okay, the answer for this is C. Let's read the question. 2 cards are drawn from a regular deck of 52 cards. What is the probability that both will be 7s? So let's go ahead and draw the first card. The probability of getting a 7 would be 4 out of 52 or 1 out of 13. Then the probability of drawing the second 7, since you've already drawn one, you will have 3 7s left. So it'll be 3, and there's only 51 cards left in the deck. So it'll be 3 out of 51, reducing to 1 over 17. If you consider the first draw as an event A and the second draw as event B, the question is, what is the probability of both events occurring, which is probability of event A and B is equal to probability of event A times probability of event B, which is simply 1/13 times 1/17, and you have 0.005. Try this one on your own and then run the video for the answer. Okay, the answer for this one is A. Best way to handle this is by a Venn diagram. In a class, there's 250 students altogether. 175 take mathematics, 142 take science. How many take both mathematics and science? So the mathematics is a total of 175 minus the number of students that take both. And science is 142 minus the number of students that take both. But we know that there are 250 students. So 250 is equal to 175 minus x plus the number of students that take both plus the 142 minus x. And a simple algebra will tell you that the number of students that take both is 67. So this was a pretty good sample of the probability questions you should expect in SAT math. So rerun the video and try these problems again and make sure you understand the various types of questions. Thanks for listening. Goodbye.